Hello, welcome to CREATA Classes. I am Gurmeet Singh and also welcome to our new series on Class 10th Chapter 9, Some Applications of the Trigonometry. And in this series, we will cover all these lectures using the power of visualization. Hope you will love our new way of teaching and the creative way of teaching. And apart from this lecture series, we also have a quiz and the PDF of the concept and formula list. Check the link in the description. And especially in this lecture, we will cover NCERT example question number 5 to question number 7. And again, do not underestimate the NCERT example questions. They are beautifully designed and well written. So without taking any further time, let's start with this lecture. Best of luck, and here is the lecture. The shadow of a tower standing on a level ground is found to be 40 meters longer when the sun altitude is 30 degree than when it is 60 degree. Find the height of the tower. So let's observe this question. This question is talking about a shadow of a tower. So firstly, let's take a tower. Let's assume the height of the tower as AB. A is the top point and B is the bottom point. So this is a tower and this tower is casting a shadow. And in the question, the shadow of this tower is given at two different times when the sun is at two different locations. In the first case, the sun is at an altitude of 30 degree and it is casting the shadow. So here this angle is 30 degree, the angle with respect to the sun. Let's mark the shadow as BD. We have taken a point D. BD is the length of the shadow of the tower AB when the sun is at angle of 30 degree. Got it? In the second case, the sun has gone to an altitude of 60 degree angle. Now sun location has been changed. So the location of the shadow has also been changed. Now the shadow at 60 degree has been shrinked. Let's mark the shadow as BC. Initially the shadow was BD. Now shadow has been shrinked to BC. And the observer has noted that the difference between the shadow length is 40 meter in the two cases. It means this distance is 40 meter. Initially the shadow was BD. Now the shadow is BC. So the difference between both the cases is 40 meter. Got it? So this is the scenario, and in this question we have to find the height of the tower. Very good question. In the previous question we have seen that two triangles are having the same base. In this question you will see that the two triangles will have the common perpendicular. This is the beauty of the NCERT question. So you don't have to underestimate the NCERT questions. They are beautifully designed in a proper sequence so that your understanding can be enhanced in a sequential order. Okay? So let's further proceed with this question. Here are you able to observe two triangles? First, the triangle is ADB, the big triangle with the angle as 30 degree. The second triangle is ACB with the angle as 60 degree. For the time being, let's take both the triangle out of the figure. For simplicity, let's mark the height of the tower as H, AB as H, and the distance BC as X. Just for the simplicity, you can proceed otherwise too. So here these two triangles are sharing the common side AB. For both of this triangle, AB is the perpendicular. For the triangle ABC, AB is perpendicular and BC is base. For the big triangle ADB, AB is again the perpendicular and BD is the base of this triangle. Okay. So let's take the triangle ABC and let's apply the trigonometric formula. Here let's use the formula of tan theta, which is perpendicular upon base. Why we are using tan theta? Because here we have to find the height of the tower. That is AB, that is perpendicular, and further the base is also coming into the picture as the length of the shadow is given in the question. Length of the shadow in both the triangle is the base. So base and perpendicular are coming into the picture, that is governed by the tan theta. Tan theta is perpendicular upon base. That's why we have taken the tan theta. So here tan 60 degree is equal to AB upon BC, which is H upon X. So we got tan 60 degree is equal to H upon X. Let's also refer the trigonometric ratio table for the value of tan 60 degree, which is root 3. So we got root 3 is equal to H upon X. Let's solve for H. We got H as X root 3. Here H is the perpendicular, which is the distance AB for this triangle. And if you observe, both the triangle are sharing the common perpendicular, that is AB is common in both the triangle. So let's take the value of AB, that is X root 3, also applicable for the second triangle. So let's go to the second triangle, the triangle ABD, and let's apply the trigonometric ratios formula in this triangle. Here AB is the perpendicular and BD is the base. And just now we have seen the perpendicular H is equal to x root 3 and BD, that is base, is composed of two line segment. If you refer the main figure, here BD is this complete length which is composed of DC plus BC. And DC is 40 meter and BC is x meters. So the complete length BD will be equal to x plus 40. Got it? We got the perpendicular as x root 3 and the base as x plus 40. Now let's apply the trigonometric ratio of tan theta. Why? Because again here perpendicular and base are coming into the picture and the relation governing the perpendicular and base is tan theta. So we got tan theta is equal to perpendicular upon base. So tan 30 degree is equal to AB upon BD, which is equal to x root 3 upon x plus 40. Okay, we have simply replaced perpendicular and base with their respective values. Let's refer the trigonometric ratio table for the value of tan 30 degree, which is equal to 1 upon root 3. Tan 30 degree is equal to 1 upon root 3. So let's solve this equation for the value of x. On solving, we got the value of x as 20. Further in the question, we have to find the height of the tower, that is h, and h is equal to x root 3. Let's put x as 20. We got h as 20 root 3. Therefore, the height of the tower is 20 root 3 meter. That is the answer of the question. Got it? Here both the triangles are sharing the same perpendicular. So we have solved both the triangles separately with the perpendicular as common. That is h. And finally, we have equated both the triangles with the common perpendicular. Interesting question. So we have done with the example number 5. Let's move to example number 6. The question is, the angle of depression of the top and the bottom of a 8-meter tall building from the top of a multi-storied building are 30 degree and 45 degree respectively. Find the height of the multi-storied building and the distance between the two buildings. So this is the question. This question is talking about the angle of depression. The previous questions we have done, all those questions involve the angle of elevation. That is when we are looking upward. Here the angle of depression is coming into the picture. That is we are looking downward. Let's see what is given in the question. In the questions, two buildings are given. One is a multi-story building and one is a small building. And the height of the second building is given as 8 meter, which is the small building. And the angle of depression from the top of the multi-story building to the top and the bottom of the small building is given as 30 degree and 45 degree respectively. It means from the top of this multi-story building, we are looking downward toward this small building. We are looking at 2 points. Firstly, we are looking at the top of that building, and secondly, we are looking at the bottom of the building. When we are looking at the top of the building, the angle of depression formed is 30 degree. And when we are looking at the bottom of the building, the angle of depression formed is 45 degree. And what is the angle of depression? It is the angle when we are looking downward and it is formed between the line of sight and the horizontal line. Do not be confused with the vertical line. Do not take these angles at the vertical position. That will be wrong one. This is a common mistake done by the students. Further, let's mark the height of the multi-storied building as PC. P is the top and C is the bottom. And also mark this building as A and B. A is the bottom part and B is the top part. And also let's take this point as Q just to denote the angles. Here the angles are 30 degree and 45 degree. Let's form a straight line from the point B toward the PC. Let's mark this point as T. Here AC, BD and QP, these three line segments are parallel to each other as these three are the horizontal line. Can we say these two angles are equal to each other? That is, this angle is 30 degree, so this angle will also be equal to 30 degree. And also these two angles are equal. If this angle is 45 degree, this angle will also be equal to 45 degree. Think, why these angles are equal? The same concept, just the hint we have covered in the theory part. Here the concept of transversals will be applicable. If we take QP and BD as the two parallel lines and BP is the transversal, we can say these two angles are the alternate angle. and in case of the transversal, the alternate angles are equal. So these two angles, that is 30 degree, will be equal to each other. Got it? Similarly, if we take QP and AC as the two parallel line and PA as the transversal, then these two angles are the alternate angle which will be equal to each other. This is the important concept and mainly used with the angle of depression. Mainly angle of depression are given on the top side and the triangle formed is on the bottom part. So somehow we have to transfer this top angles to the bottom part. And here our concept of transversals comes to picture. Okay? So this is the concept and just note it down. This is very important. Let's further solve this. Here, are you able to observe these two triangles? The triangle PBD and the triangle PAC. In the triangle PBD, our trigonometric angle is angle 30 degree. And in the triangle PAC, our trigonometric angle is 45 degree. And the interesting thing is that both the triangle are having the same base. How? For triangle PBD, the base is BD. And for the triangle PAC, the base is AC. And here BD and AC are equal to each other. That is, these two line segments are equal. So both the triangle are sharing the common base. So the approach that we will use to solve this question is, firstly we will solve this triangle and find the BD. Then we will solve this triangle and find the AC. Then we will equate BD and AC as both are equal to each other. Or we can solve the triangle PBD and find BD and put the value of BD in the second triangle. Whichever approach is convenient to you, we can use that. Got it? So you got the basic approach how to solve the question. Rest is just the simple mathematics. So let's take the triangle PBD. Here base is BD and PD is the perpendicular. Here tan theta will be applicable as perpendicular and base are coming into the picture. So tan theta is equal to perpendicular upon base. So tan 30 degree will be equal to PD upon BD. And what is the value of tan 30 degree? It is 1 upon root 3. So we got 1 upon root 3 is equal to PD upon BD. On solving, we got BD as equal to PD into root 3. Okay, we have solved for the value of BD. Why? Because in the second triangle also the base is same. So we can use this value to solve for the second triangle. Let's see how this is applicable. Let's take the triangle PAC. Here again, let's apply tan theta, which is perpendicular upon base. So tan 45 degree will be equal to PC upon AC. And the interesting thing with the tan 45 degree is that perpendicular and base will be equal to each other. How? Let's see. Tan 45 degree, the value is 1. So we got 1 is equal to PC upon AC. That is PC is equal to AC. That is perpendicular is equal to base. This is very interesting with 45 degree angle. Perpendicular and base both are equal to each other. So we got PC is equal to AC. And just now we have discussed that AC and BD both are equal to each other. AC is equal to BD. If we compare both of this equation, we got BD is equal to PC. Got it? We have just compared both of this equation. We got BD is equal to PC. BD is the distance between the two buildings and PC is the height of the multi-story building. Both are the missing dimension that we have to find in this question. Further, we have just calculated BD as PD root 3. So let's replace BD with PD root 3. Further, if you observe PC, the height of the multi-story building, it is composed of BD and DC, the two components. PC, it is composed of PD and DC. So we can replace PC with PD plus DC. The simple mathematics, nothing special we have done. We have just replaced PC with PD plus DC and we have replaced BD with PD root 3. Got it? Further, what is DC? If you observe the main diagram, DC is the height of the second building, the small building, which is given as 8 meters. So we can replace DC with 8 meters. So we got PD root 3 is equal to PD plus 8. Now we got an equation in which only one variable is there, that is PD. Let's rearrange the equation and solve for PD. We got PD as 8 upon root 3 minus 1. Here we can put root 3 as 1.732 and solve this equation. But in the question it is not given the value of root 3. But we can use that. But here we will use the alternative method. That is, we will use the rationalization. Let's multiply the numerator and denominator with root 3 plus 1. Here in the denominator, we got root 3 plus 1 into root 3 minus 1, which is resembling a plus b into a minus b, which is a square minus b square, the simple algebra. So on solving, we got PD as 4 into root 3 plus 1 meters. So let's find the height of the multi-story building, which is PC, and PC is equal to PD plus DC. And just now we have calculated PD as 4 into root 3 plus 1 and DC is equal to 8 meter. So our answer, that is the height of the multi-story building, will be equal to 4 into root 3 plus 3. The simple mathematics we have applied. The second part of the question is demanding for the distance between the two buildings. And distance between the two buildings is AC, which is equal to PC. And just now we have calculated the PC. So AC, that is the distance between two buildings, is also equal to 4 into root 3 plus 3. That is the answer of the question. Got it? So the understanding that we got from this question is that whenever we are having the question of angle of depression, in those cases we have to look downward. That is, angle of depression is looking downward and angle of elevation is looking upward. The second thing is that whenever we are having angle of depression, the case of transversal and the alternate angle will come into the picture. And you have to transfer the angle at the top to the bottom part so that you can use the trigonometry in the below triangles. So this is the understanding about the angle of depression that you got from this question. So we have done with the example number 6. Let's move to example number 7. Example number 7. From a point on a bridge across a river, the angle of depression of the banks on opposite sides of the river are 30 degree and 45 degree respectively. If the bridge is at a height of 3 meters from the banks, find the width of the river. So this is the question, and this question is also talking about the angle of depression. But our first step, we will observe the question and we will try to locate a right angle triangle in the given scenario. Let's see what is given in the question. In this question, a bridge is given which is across a river. So river is below this bridge. Further, a point is also given on the bridge. Let's take this point as point P. From this point P, the angle of depression of the banks on opposite sides of the river are given as 30 degree and 45 degree respectively. Angle of depression when we are looking downward, it is the angle between the horizontal line and the line of sight. So from this point P, let's join the two opposite banks of the river. We got these two line segments. Let's give the 2 points on the opposite banks of the river as A and B. Here the angle of depression are 30 degree and 45 degree respectively. It means these angles are with respect to horizontal line. Don't do the mistake of making the angle with respect to the vertical line, a common mistake done by the students. Angle of depression or the angle of elevation is with respect to the horizontal line. Here 30 degree and 45 degree are with respect to this horizontal line. So don't confuse. Further in the question, the height is given as 3 meters. That is this height, the height of the bridge is given as 3 meters. And we have to find the width of the river. It means we have to find the distance AB, that is the width of the river. So this is the scenario given in the question. Are you able to observe a triangle in the given figure, the triangle PAB? Is this triangle a right angle triangle or not? Let's check it out. Here the two angles are given as 30 degree and 45 degree. And we know on a straight line the sum of angles is equal to 180 degree. It means sum of these three angles will be equal to 180 degree. That is 30 degree plus angle APB plus angle 45 degree is equal to 180 degree. We got angle APB as equal to 105 degree. So this angle is not a 90 degree angle. So this is not a right angle triangle. Got it? The simple calculation we have done to identify the triangle is a right angle triangle or not. It means our first step is still pending, that is identifying a right angle triangle in the given scenario. So let's try to make a right angle triangle in the given figure. For that, let's draw a perpendicular line from the point P towards the line AB. We got PD. These two angles are 90 degree as PD is perpendicular to AB. By doing so, we got two right angle triangle. Once we got the right angle triangle, we can apply our trigonometric ratios formula. So we have done our first step. We have identified the two right angled triangles. Further, here angle of depression is given in the question. It means the case of transversal will come into the picture. Similar to the previous question, the example number 6. Here these two lines are horizontal line. It means they are parallel to each other. And if we take AP as an transversal, can we say these two angles are the alternate angles and will be equal to each other? Got it? The simple case of transversal. These two lines are parallel. AP is a transversal. So these two angles are alternate angles which are equal in case of parallel lines. Similarly, if we take BP as a transversal and these two line segment as a parallel line, we can say these two angles are equal to 45 degree. Got it? Both the angles are equal, the alternate angle, same philosophy. So we got the two triangle and we also got the trigonometric angle of both the triangle. For the triangle PDA, our trigonometric angle is 30 degree. For the triangle PBD, our trigonometric angle is 45 degree. The approach that we will use is, in the first triangle, we will apply the trigonometric ratio and we will find the distance AD. Similarly, in the second triangle, we will apply the trigonometric ratios and we will find the distance BD. Finally, we will add AD and BD, these two line segments, to get the complete length AB, which is the width of the river. That is the question framer is asking in this question. So this approach we will use. Firstly, let's take the triangle PDA. In this triangle, PD is the perpendicular and AD is the base. And our trigonometric angle is angle 30 degree. And what is the relation between the perpendicular and base? It is tan theta, right? So tan theta is equal to perpendicular upon base. One interesting thing that you might have noted in the previous questions too, we have done 7 questions. In all the 7 questions, only the trigonometric ratio tan theta is coming into the picture. We have not dealt with sin theta, cos theta or any of the other trigonometric ratio. But it does not mean that in these questions only tan theta will be applicable. As per the different scenario, as per the different type of question, sin theta and cos theta can also come into the play. So be cautious of it. Do not blindly go with the tan theta. As per the different scenario, you have to think which trigonometric ratio you have to use. In this question, no doubt tan theta will be applicable, which is equal to perpendicular upon base. So tan 30 degree will be equal to PD upon ED. And what is PD? It is 3 meter. And what is tan 30 degree? For that, let's refer the trigonometric ratio table, which is 1 upon root 3. Okay. Note that tan 30 degree, tan 45 degree and tan 60 degree. These three trigonometric ratios will be mostly used in height and distance question. So you should memorize them. Tan 30 degree 1 by root 3, tan 45 degree it is 1 and tan 60 degree it is root 3. These three values will be used multiple times in the different questions. So you should know them. Further, let's solve it. We got AD as 3 root 3 meter. One part of the question we have done. So let's take the second triangle, the triangle PDB. In this, let's apply the trigonometric ratio, that is tan theta. Tan theta is equal to perpendicular upon base. So tan 45 degree will be equal to PD upon BD. PD is the perpendicular and BD is the base. And what is tan 45 degree? Just we have seen in the trigonometric ratio table. It is 1. This you should know. And PD is 3 meter. On solving, we got BD as also equal to 3 meter. In the first part, we got AD as 3 root 3. In the second part, we got BD as 3 meter. Let's find the complete length AB, that is the width of the river, which is BD plus AD, that is 3 plus 3 root 3. So we got our answer as 3 into 1 plus root 3 meter. That is the answer of the example number 7. Got it? We have done with the question number 7. So students, we have done with this lecture. Hope you have enjoyed our new and creative way of teaching. If so, like the hit button, subscribe to our YouTube channel and also share this video with your friend. And do not forget to download the PDF of the concept and the formula list, and also check the link to the quiz in the description. So that's it for this video. Thank you very much for being with CREATA Classes. Bye for now. Best of luck and have a great day.